to help you understand slope fields, what they are, how to do them, how they work. That's what this worksheet's about. What we're going to do is we're going to do a few of these problems together, okay, to help you understand how to do them and what they are. And I did talk about them briefly the other day. The idea of a slope field is that I have a differential equation. In this case, my differential equation dy dx equals x plus 1. A slope field is a way of finding all of the general solutions to a differential equation. And what is that differential equation? Dy over dx represents what? The slope of the line. That represents the slope of the original equation, right? When you take the derivative, that gives you, one use for the derivative, I should say, is the slope. It's the rate of change. If we plug in particular values, that gives us the slope of the original equation at that coordinate, at that xy coordinate. Okay, when x and y are 1, what is my slope of the original line? That's how a slope field works. It gives us little portions of the original equations of all possible solutions to this. Because that's what we're doing here. Rather than drawing every single complete curve, we're just finding little portions. What little portion there is at that particular xy coordinate of all possible ones. Okay? Now, I realize there are a lot of points here on this one. Get over it. Partially because this is also, on this one in particular, a very easy one to do. Because what we're doing on this is we're creating a slope field. We are going to create that. So what you have to do is for every xy coordinate, figure out what dy dx is at that point, and put a little dash that has the slope of the number we calculated. So for example, what is dy dx at the coordinate 1, 1? So I want to evaluate the derivative at 1, 1, or evaluate that differential equation at 1, 1. Well, that's actually pretty easy. It's 1 plus 1, which is 2. So what I want to do, and you don't have to be exact, but you do want to, and there's some tips and tricks here and things that I'm going to point out what my expectations are and what the expectations of AP are. You want to get a slope close to 2. So at the coordinate 1, 1, I have a line with the slope approximately like that, a slope of 2. Because at the point 1, 1, my differential equation is 2. My differential equation is equal to, or sorry, yeah, my differential equation is equal to 2 at that coordinate. So I have a little dash with the slope of 2 at that coordinate. Okay. Same thing for any other coordinate. dy dx at the point, let's say 0, negative 1. Well, that's 0 plus 1, which is 1. So at the 1, 0, negative 1, I have one that's a slope of 1. Do you see where I'm going? Do you see where I'm going with this? It doesn't matter. I can do this, and you kind of need to do it for every single coordinate. Let's say negative 2, 2. Which is negative 2 plus 1, or negative 1. So at the coordinate negative 2, 2, right here, I have a slope of negative 1. Now, a couple of things to help you fill this out. First thing I want you to notice is look at the differential equation. I've got dy dx on one side, but what do I have on the other side? I only have x. I don't have any y coordinates. The y coordinates are irrelevant for this particular differential equation, which makes it nice, which means vertically, every single dash vertically will be exactly the same. So I know, because I got negative 1 here, every single one of these is going to be a slope of -1. Because x is equal to -2 in every one of these. -2 plus 1 is -1 for every one of these. The y is irrelevant because there's no y in this differential equation. So that makes it nice. Ooh, I've already figured this one out. This has a slope of 1. This one has a slope of 2. What about this row here? What's its slope going to be? It's going to be 0 because x is -1. -1 plus 1 gives me a nice 0 slope. Okay. Now, it gets a little more difficult from here, at least from the sketching standpoint. But here's what I'm looking for here. You better get your horizontal lines correct. And you better get any vertical dashes you have correct. Anything that's undefined, you get a vertical dash. Anything that's 0, you get a horizontal dash. You better get those right. And here's what I need to know from here on out. What's happening? This is a slope of 1, a slope of 2. This one's going to have a slope of 3 and a slope of 4. What's happening with my slopes as I'm going farther along? They're getting steeper. I do not expect you to give me exactly a slope of 3 here, but it better be steeper than the slope to the right. So what I'm looking for here is increasing steepness. And this one's going to be even steeper still. Yeah, say that a bunch of times. Okay. And the same thing goes in the other direction. I'm starting to get a negative slope. This one's going to be a slightly steeper negative slope. And that's what we're looking for. Okay. What kind of shape do you see in here? You see a parabola. And if I take the antiderivative of x plus 1, I get 1/2 x squared plus x. And then plus c. The plus c determines which one of these I go through. Okay? Does that make sense? Slope fields aren't that difficult. Okay? So that was the first one. We did one together. Second one, a little more difficult, but the concept is the same. Okay? So, here's what you want to do. Same idea, look at the patterns you have. So I have dy dx, evaluated at, let's say, 1, 1. Come on in, have a seat. Okay. Plug in 1, 1. 1 plus 1 is 2. So this one has a slope of 2. It's about like that. Gonna have to do a lot more of them. You're actually almost gonna have to do them all because it's not consistent. If it has x only, they're all gonna be the same vertically. If it has y only, they're gonna be all the same horizontally. If you have an x and y combination, yeah. Now there are still some shortcuts here. What is it going to be when x and y are opposites? 0. So when I have so at the point 2, -2, -1, -1, 0, 0 will also be 0. I can go ahead and sketch those in. Anywhere where it's opposite, I get a slope of 0. So I'm going to, okay, that would be this one here, this one here, this one here, this one here, this one here. So I can sometimes get a few shortcuts, but not always. Okay, this is a simple one. Add the x, y coordinates together and plug them in and do what you can. Now, it's really easy on the x-axis. They're all whatever the y coordinate is. Or sorry, they're all whatever the x coordinate is. On the y-axis, they're all whatever the y coordinate is. That makes those easy, right? So you can fill those in. And it's the ones on the outlying areas you just have to add the points together to get your slope. So go ahead and work on filling the rest of this in. Very interesting graph. It's a very interesting graph. We will learn how to find the anti. We will find and solve algebraically dy dx equals x plus y. You will learn how to do that. Actually, very interesting looking graph and do that. Okay. And for smarts and giggles, pick a point. Let's go through the origin. So our plus c would be whatever we get from that, and it might not be 0. Our plus c might not be 0. And if you follow, you get something that looks like that. It's not quite a parabola. I'll tell you right now, I think off the top of my head, this would be y equals e to the x squared. Actually, y equals e to the x squared over 2. Y equals e to the 1/2 x squared. That's what I believe the antiderivative plus c. I believe the antiderivative on this one is. We'll be able to work it out later. You do not yet possess those skills. You will not possess those skills till the end of this chapter, but you will possess them by the end of the chapter. It's not as hard as it looks. There are some you can't separate though. Like sine of xy. You have the sine of xy. You can't separate that and solve it. The only way you can do that is a slope field and learn how to do that slope field on your calculator. Okay, and I would never ask you to do that. Neither would AP would ever ask you to do something like that. Okay, so you guys get the idea of how to do a slope field? Okay, so the first page is basically doing that. Let's get to the next one. And here's the one that's a little harder. AP multiple choice questions. I've seen one of these on every multiple choice question I've been able to get for the last few years. This didn't used to be part of the AP calculus. They added it on about 6-7 years ago. They made this part of the AB curriculum. It used to be just BC, now it's AB. And if they do ask you on the test, they have you make a small slope field, much smaller than the one I'm asking you to do, much fewer points than what I asked you to do. Or this. They give you a slope field and say, no, which equation goes with it? And you have to match it. Which means you got to use a little common sense in some of what you do. So, I look at this one here and I go, all right. First one, A. It's going to be one of these choices. Every single one of the vertical ones are all the same. So every single one of the vertical ones are all the same. That means y is not part of my differential equation. So obviously that works because none of these have a plus y. Okay, that sucks. Next thing you need to do is figure out which ones of these match. Now, notice what's going on at x equals 0. At x equals 0, it looks like I have vertical slopes because they line up, right? You don't see anything else. If it was horizontal, you'd see a little horizontal one. Like here, it's horizontal because these are all horizontal. You can't see it, so this is going to be vertical, which means I have an undefined slope at that point. That means whatever this is has to be equal to 0 when x equals 0. Well, what possibilities do I have? Or actually, not 0. It has to be undefined at that point. My bad. It has to be undefined at that point. Which ones are undefined when x equals 0? This one right here, and that's it, because, oh, this one. It's also undefined in x equals 0. You cannot take the natural log of 0. It doesn't exist. So technically it could be this one. Okay? Sine, cosine doesn't seem to work. So the question is, does this look like a logarithmic equation, or does this look like x squared? Okay? What is the natural log of 1? 0. So when I put in 1, do I get 0? No. So it's not that, which leaves us so then this one here, we have to match it up. Which one does it match up with? Well, I look at that. What do you see? What do you see in here? Sine or cosine? Yeah. In this case, it would probably be, it could be either one of them, but I believe this would be the cosine one because the hump is on the y-axis. Okay, that's a cosine curve. If you look at it, what do you see? You see the waviness, right? And where's the hump? The hump is, so remember, cosine has the hump on the x-axis. Sine passes through the x-axis in an angle. You have to know what sine looks like. You have to know what cosine looks like and tell the difference between the two. Okay. Same thing on the next one. This one's a little harder. They all do include x and or y, possibly. So I look at this and I go, okay, if it was this one, all of my x values would be the same. Okay, all of my x values would be the same. Are all my x values the same here? Are all my x values the same here? Yeah. Does it seem to work on here? 1/2 x plus 1. So at -2, if I put -2 in there, what do I get? I get 0. If I put 0 in there, what do I get? I get a slope of 1. If I put 1, this one seems to match. 15 seems to match this one. All the x's are the same. That's the only one that has only x. So that goes with that one. Okay. And this is a deduction kind of thing. So we've already eliminated that. So all we're doing is focusing on this. For it to be dy dx equals y, that means every y coordinate, every horizontal one has to be the same. Are the horizontal ones the same? No, so this one is eliminated. So our choices are x minus y or x over y, negative x over y. Plug in a few points and see what you get. If I put in the coordinate 1, 1. 1 minus 1 is 0. So at the coordinate 1, 1, do I have a 0 slope? And if I have 1, 1 here, what do I get? -1, right? That's what matches. Process of elimination. Okay, matching them up. Okay. Matching them up. What shape is that? It's going to be a circle. This is the antiderivative of this is a circle with a radius, whatever. The plus c determines the radius. That one is once again a parabola. Okay. So you'll kind of start to see them, but that's what you're doing on these. Okay. Any questions on that? So